Welcome back. In this new series, we shift focus from global patterns to area-specific climatology. That means understanding the unique weather traits of different world regions, essential knowledge for flight planning and route selection in any type of operation. Let's start with Western Europe. This region sits in the mid-latitude westerly belt, where air masses constantly mix. That creates frequent frontal activity, occluded depressions, and variable wind patterns, especially in winter. Airports in the UK, France, and Germany often face low ceilings, stratus and fog, icing layers between 2,000 and 10,000 feet. Pilots must plan alternates carefully, especially in cold seasons with persistent IMC. Moving south, the Mediterranean brings its own challenges. In summer, it's mostly dry and stable. But autumn and winter bring intense lows, especially over Italy and Greece, with thunderstorms, gusty winds, and poor visibility. The Mistral and Bora winds, common in southern France and the Balkans, create strong, dry, downslope winds. Expect clear air turbulence, crosswind landings, and sudden weather changes, especially near mountain ranges. Let's look east to Eastern Europe and Russia. In winter, expect extremely cold temperatures, fog, and low vis, especially near rivers and valleys. Summer brings CBS and convective activity, but lower icing risk. In remote Russian regions, alternate airports are sparse, and fuel availability may be limited. Planning requires high reserves and awareness of surface conditions, especially with snow or freezing rain. Now on to Northern Africa and the Sahara. Most of the year is hot, dry, and clear, but that brings issues too. Expect density altitude problems, dust storms, and strong thermal turbulence in the afternoon. One major hazard is the harmattan, a dry, dusty wind that reduces visibility across West Africa. During harmattan season, even VFR operations may be impossible due to widespread haze. Heading south, Central Africa sits in the equatorial zone. That means year-round convection, high humidity, and limited visibility. Expect towering CBS and late afternoon storms, often with no META or radar support. In the rainy season, flooding may close airports or make alternate runways unusable. Pilots must use satellite tools and plan for high fuel reserves and daylight-only ops in remote strips. Let's move to the Middle East. Summers are hot, dry, and mostly stable, but temperatures above 45 degrees Celsius can affect engine performance and require payload reductions. Expect strong LLWS and dust near desert terrain. In winter, radiation fog becomes common overnight, especially in valleys. Places like Dubai or Riyadh can go from clear skies to zero visibility in minutes, delaying departures and disrupting schedules. In South Asia, the big player is the monsoon. From June to September, India and neighboring regions face heavy rain, low clouds, and CBS. Delays and diversions are common, especially at coastal airports. During the pre-monsoon season, expect strong thermals and thunderstorms, especially inland. In winter, northern India faces dense fog, especially around Delhi, causing visibility to drop below minima for hours. Let's now look at Southeast Asia. Here, convection dominates year-round. Expect tropical storms, low-level wind shear, and frequent CBS, especially in the afternoon. Most flights take place in marginal VFR or light IMC. Smaller airports may lack radar or alternate support. Pilots often rely on visual navigation, especially in island regions like Indonesia or the Philippines. Daylight ops and terrain awareness are key. In East Asia, countries like China, Korea, and Japan see extreme seasonal variation. Winters bring strong Siberian highs, causing cold outbreaks and crosswinds, while summer brings typhoons and heavy rain. In spring and autumn, frontal systems can stall over the region, creating widespread IMC and icing between FL 100 or FL 200. Dispatch must stay flexible with alternates across different climate zones. Let's head to Australia and New Zealand. The north is tropical, while the south is temperate. In summer, Australia sees bushfire haze, CBS, and high temperatures. In winter, the south faces fog, frost, and low stratus. New Zealand's mountain ranges bring rapid weather shifts, especially on the west coast. Orographic lifting and turbulent westerlies can create challenges even for experienced crews, especially in VFR. Now over to North America. The US and Canada cover multiple zones. The Pacific Northwest is wet and cloudy. The Midwest has storms and snow. The South brings humidity and CBS. The Rockies mean turbulence and mountain waves. The North sees blizzards and polar air masses. Flight crews must know regional risks. For example, flying into Denver means preparing for wind shear, icing, and downdrafts, especially when the jet stream dips south over the mountains. Let's not forget Central and South America. The Amazon region faces high humidity and CBS year-round, with poor radar coverage. The Andes bring high-elevation airports, rapid weather shifts, and performance challenges. In Chile and Argentina, winters bring mountain wave turbulence, while summer storms can stretch across hundreds of miles. Flight planning must account for alternate limitations and terrain avoidance. And finally, let's talk about the Caribbean. It's mostly VMC, but between June and November, hurricanes are the biggest threat. Crews must check tropical storm tracking and be ready to cancel or divert on short notice. Outside of storm season, the main risks are microbursts, wet runways, and quickly forming CBS near coastlines. Early morning flights tend to be the calmest, storms build as the day heats up. Let's wrap up with a recap. Each region has its own climate risks: wind, fog, storms, visibility. Planning must consider terrain, seasonal patterns, and airport support. Using local knowledge and climatology improves safety and efficiency. In the next episode, we'll continue with area climatology, Part 2, focusing on seasonal charts, met data, and how to brief area risks like a pro. See you in Meteorology number 46, Area Climatology, Part 2.